Hey Algebra, we're going to do chapter 12. It's lesson 7, probability of compound events now. Remember we talked about probability at it's a ratio of kind of like the number of chances and then the number of times that you actually do the thing. If it was coins, remember, it's number of chances for either heads or tails. You either have a head or a tail, I guess is what I'm trying to say. That's 2. And the number of times you flip it, let's say we just flipped it once. What's my chance of getting heads? It'd be 1 time that you do it, and there's 2 possibilities. So maybe instead of number of chances, maybe I should write number of possibilities. That might be better. Okay. The question's often asked, what happens if we do something, twice or things that happen in a succession? So if we flipped a coin, basically what's our chance of getting something like heads and then after that, tails? These 2 events are linked. That's why it's called a compound event. We're asking about the chance of this happening and then this happening. Well, we know the chance of heads is 1/2. We know the chance of tails is 1/2. So how do we show that there's this linkage there? Well, let's just think about it just for a moment. We could have, here's 4 things that could happen when we flip a coin twice. We can get heads followed by tails. We could get heads followed by heads. We can get tails followed by heads. And we can get tails followed by tails. Right? There's nothing else that can happen. Well, we want heads followed by tails, which is this one. So that would happen 1 time out of 4 possibilities. So that's going to equal a 1 in 4 chance. So you can see here that we're not going to end up adding these. That wouldn't give us 1/4. We're going to end up multiplying. And in fact, that's the formula. When you have events that are linked together like this, and we do them consecutively or in a compound event manner, we're going to multiply the probabilities. What if it was like a bag of marbles? Say there was 10 marbles in there. There was 5 red and 5 blue. And I asked you your chance of getting a red marble. And then, I should say, after you draw the marble, you put it back in the bag. So I ask you, what's your chance of getting a red marble followed by another red marble? So our chance of getting a red marble to begin with is, we have 5 out of 10, so we have a 5 in 10 chance, or I could write that as a 1/2 chance. I think I'm just going to reduce at the end. So a 5 in 10 chance of getting a red, and then I put the marble back. I have 10 marbles again. I blindly draw, and I have another 5 in 10 shot. So I'm going to multiply these 2 events together. I'm going to get 25 out of 100. Which reduces to a 1 in 4 shot. Some things, that's like an example of something that they're independent events. They're not affecting each other. Okay, me drawing a marble the first time and then putting it back doesn't affect what happens the second time. Some things are called dependent events, and they do affect each other. Let's say I was drawing these marbles and I didn't put them back each time. Well, let me do the same thing. Let's say, what was my possibility then of getting 2 reds in a row? Well, the first time we know would be 5 out of 10. But this time we're not putting the marble back in there. So the second time there's going to be 9 marbles to draw from. There's only going to be 4 reds out of the 9. So my chance of getting another red in this case is going to be 4 out of 9. Well, my probability of getting 2 reds in a row in this scenario, I'm going to multiply those 2, so I'll get 20/90ths, reduce it. I have a 2 in 9 chance of getting 2 marbles in a row if I do not replace them. So Independent events, you just take the probabilities and multiply them together. Dependent events, you take the probability of the first one, and then however it affects the probability of the second one, you multiply it by that second probability, and you get your new probability. Some things are called mutually exclusive. In other words, they don't depend on each other at all. For instance, I don't know, let's say, what are my chances of getting, well, not that they don't depend on each other, but they can't both occur. So let's just do a dice one. What are my chances of rolling a 6 or a 5? Well, my chance of rolling a 6, remember there's 6 sides to a die, so I have a 1 in 6 shot of doing that. I also have a 1 in 6 shot of rolling a 5. The problem is I can't do them together and they don't affect each other in any way. So my chance of rolling a 6 or a 5 is going to be this probability plus this probability. In other words, if you think about it, I'm going to roll the dice one time. I've got 6 sides, so 6 possibilities. And I've got 2 events that I could happen that would work. So it's going to be 2 out of 6, which reduces to 1/3. If I do this and I add it up, it's going to be 2 out of 6, which reduces to 1/3. Okay? So mutually exclusive events, we add the probabilities of those. All right, that's all I know about probability. Don't go to Las Vegas and lose all your money.